Question 1. Q. Which of the following is cited by the scientists as evidences for the continued expansion of universe? 2012. 1. Detection of microwaves in space. 2. Observation of redshift phenomenon in space. 3. Movement of asteroids in space. 4. Occurrence of supernova explosions in space. Select the correct answer using the codes given below. A. 1 and 2. B. 2 only. C. 1, 3 and 4. D. None of the above can be cited as evidence. Answer A. Explanation. Universe. The universe is all of space and time and its contents, which includes planets, moons, minor planets, stars, galaxies, the contents of intergalactic space and all matter and energy. The universe consists of galaxies and other celestial bodies like stars, planets, satellites, asteroids, comets and dark matter. The study of the universe is called astronomy. Important astronomers and their discoveries. Ancient astronomers, Pythagoras, Ptolemy, Aryabhatta etc. Copernicus, heliocentric universe theory. Galileo Galilei invented telescope, demonstrated the validity of Copernican system. Isaac Newton discovered laws of gravity. William Herschel came out with his observation that the universe was not limited to the solar system, but is much vast and that in the solar system was only a small part of a much bigger star system, called the galaxy. Edwin Hubble postulated that apart from the Milky Way, there were other galaxies in the universe whose number ran into millions, with each galaxy containing billions of stars. Origin of the universe. Most widely accepted theory is the Big Bang theory proposed by clergy A. George Lemaitre. The Big Bang theory. In the beginning, all matter and energy was concentrated in one point called singularity. Around 13.7 billion years ago, the singularity exploded in a Big Bang and resulted in formation and expansion of universe. Within 300,000 years from the Big Bang, temperature dropped to 4,500 K and gave rise to atomic matter. The expansion of universe continues even today. Evidence for expansion of the universe. Observations by Hubble. Hubble in 1929 noted that galaxies outside our own Milky Way were all moving away from us, each at a speed proportional to its distance from us. Redshift phenomena. Astronomers measure the movement of objects relative to us using Doppler shift in wavelength of light, whereby its frequency is shifted depending on the motion of the emitting object. Cosmic background radiation. The early photons, the afterglow of the Big Bang known as cosmic background radiation, can be observed today in form of background microwave. Question 2. Q. The group of small pieces of rock revolving round the Sun between the orbits of Mars and Jupiter are called. 1997. A. Meteors. B. Comets. C. Meteorites. D. Asteroids. Answer D. Question 3. Q. Consider the following statements regarding asteroids. 1998. 1. Asteroids are rocky debris of varying size orbiting the Sun. 2. Most of the asteroids are small but some have diameters large and 1000 km. 3. The orbit of asteroids lies between the orbits of Jupiter and Saturn. Of these statements, A. 1, 2 and 3 are correct. B. 2 and 3 are correct. C. 1 and 2 are correct. D. 1 and 3 are correct. Answer C. Explanation. Important definition. Star. A star is a luminous sphere of plasma held together by its own gravity. Huge amount of energy is produced in a star's core by continuous nuclear fusion reactions. A group of stars forming various shapes when seen from the Earth is called a constellation. Major constellations: Ursa Major, Ursa Minor, Orion, Leo etc. Life cycle of star. Galaxy. These are huge congregation of stars that hold together by force of gravity, e.g. the Milky Way, Andromeda Galaxy, Ursa Minor system, Sculptor system, etc. Milky Way or Akashganga is our home galaxy. Our solar system is located in this galaxy. It is spiral in shape and rotates slowly about its axis. It takes about 250 million years to complete one revolution. Our Sun is just one of the 100 billion, 10^11 stars in our galaxy. Andromeda Galaxy is the closest neighbor galaxy, which is 2.2 million light years away from us. Planets. Planet is an astronomical body orbiting a star or stellar remnant that is massive enough to be rounded by its own gravity, is not massive enough to cause thermonuclear fusion, has cleared its neighboring region of planet simals, smaller debris. Natural satellite or moon. A natural satellite or moon is an astronomical body that orbits a planet or minor planet, or sometimes another small solar system body. Solar system. A solar system is the gravitationally bound system of a star and the objects that orbit it, either directly or indirectly. A solar system may consist of one or more stars which are surrounded by different revolving celestial bodies which are classified as planets, comets, satellites or moons, asteroids, etc. Our solar system. Our solar system consists of the Sun, 8 planets, their satellites, asteroids, comets and dwarf planets. There are 8 planets in our solar system: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune. The planets are divided into inner or terrestrial planets which have higher densities, e.g. Mercury, Venus, Earth and Mars, outer or Jovian planets which have lower densities, e.g. Jupiter, Saturn, Uranus and Neptune. The Sun. Sun is about 150 million kilometers away from the Earth. The light from the Sun reaches Earth in about 8 minutes. The glowing surface of Sun is called photosphere. Above the photosphere is red-colored chromosphere. Beyond chromosphere is corona, visible during eclipses. The temperature of the photosphere is about 6,000 degrees Celsius and that of the chromosphere is about 32,400 degrees Celsius, and that of the corona about 2,700,000 degrees Celsius. In the Sun's interior, like any other star, hydrogen gets converted into helium, generating tremendous amount of heat, fusion nuclear reaction. It takes 250 million years to complete one revolution round its center. This period is called cosmic year. Sunspots are dark patches notched on the surface of the Sun. They appear dark because they are cooler, i.e. they have a temperature of about 1,500 degrees Celsius. Mercury. Mercury is the smallest and the nearest planet to the Sun. It takes only 88 days to complete one round along its orbit. It has no atmosphere and no satellite. Mercury is similar to the Moon with a surface dominated by craters and a younger area of dark plains presumably made from floods of lava. Venus. Venus is considered as Earth's twin because its size and shape are very much similar to that of the Earth. It is also called the morning or evening star. It is probably the hottest planet because its atmosphere contains 90 to 95% of carbon dioxide with clouds of sulfuric acid. The day and night temperatures are almost the same. It rotates from east to west. It has no satellite. Mars. It is marked with dormant volcanoes and deep chasms where once water flowed. It has a thin atmosphere comprising of nitrogen and argon. Mars is barren. Because of this it is known as red planet. It has 2 satellites, namely Phobos and Deimos. Its red color comes from iron oxide rust in its soil. Asteroid belt. Millions of objects, remnants of planetary formation, circle the Sun in a zone lying between Mars and Jupiter. They are known as asteroids. Fragments of asteroids break off to form meteoroids, which can reach the Earth's surface. Asteroids are small solar system bodies composed mainly of refractory rocky and metallic minerals, with some ice. Asteroids range in size from hundreds of kilometers across to microscopic. All asteroids except the largest, scie3, are classified as small solar system bodies. Jupiter. Largest planet of the solar system. Its atmosphere contains hydrogen, helium, methane and ammonia. It has the Great Red Spot, which is an enormous area in the turbulent cloud cover. It also contains dusty rings and volcanoes. Number of moons equals 79. Planet with highest number of moons. Jupiter's 4 large moons, Io, Europa, Ganymede, and Callisto, called the Galilean satellites because they were discovered by Galileo in 1610. Saturn. It is the second largest planet of the solar system. It is composed mostly of hydrogen and helium. It has rings composed of thousands of spiraling bands of icy rock and dust. It has 62 known satellites. Among them Titan, Phoebe, Tetis and Mimas are important. Its moon, Titan, has nitrogen atmosphere and hydrocarbons, the necessary compounds for life. Uranus. It is the only planet that lies on its side. Hence, one pole or the other faces the sun as it orbits. It rotates north to south. Its atmosphere is made of mainly hydrogen. The landscape is barren and there is frozen methane cloud. There are 9 dark compact rings around the planet and a corkscrew-shaped magnetic field. It has 27 satellites. Prominent ones are Ariel, Umbriel, Titania, Miranda, etc. Neptune. There are 5 rings of Neptune. The outer ring seems to be studded with icy moonlets while the inner ring appears narrow and nearly solid. It has 8 satellites like Typhon, Merid, etc. Its atmosphere mostly contains hydrocarbon compounds. It appears blue, with quickly changing white icy methane clouds often suspended high above an apparent surface. Kuiper Belt. The Kuiper Belt, aka Kuiper Edgeworth Belt, is an area of the outer solar system that is estimated to stretch across 20 astronomical units of space. It contains small solar system bodies made mostly of ice, which is the frozen volatiles, gases, such as methane, ammonia, nitrogen and water. It also is home to the known dwarf planets Pluto, Haumea and Makemake. Pluto. The dwarf planet Pluto, 39 astronomical units average, is the largest known object in the Kuiper Belt. When discovered in 1930, it was considered to be the 9th planet. This changed in 2006 with the adoption of the formal definition of planet. Pluto was moved into the list of dwarf planets along with Ceres and Eris. Charon is Pluto's moon and nearly half its size. Comets. A comet is an icy small solar system body that, when passing close to the sun, heats up and begins to outburst, displaying a visible atmosphere and sometimes also a tail. Usually originate in the Kuiper Belt or its associated scattered disk, which lie beyond the orbit of Neptune. Mostly made up of dust, ice particles and gases. May be periodical or non-periodical. Example of periodical Halley's comet appears every 76 years, first sighted in 1986. Question 3. Q. Consider the following statements regarding asteroids, 1998. 1. Asteroids are rocky debris of varying size orbiting the sun. 2. Most of the asteroids are small but some have diameters large and 1000 km. 3. The orbit of asteroids lies between the orbits of Jupiter and Saturn. Of these statements, A. 1, 2 and 3 are correct. B. 2 and 3 are correct. C. 1 and 2 are correct. D. 1 and 3 are correct. Answer C. Explanation. Asteroid belt. Millions of objects, remnants of planetary formation, circle the sun in a zone lying between Mars and Jupiter. They are known as asteroids. Fragments of asteroids break off to form meteoroids, which can reach the Earth's surface. Asteroids are small solar system bodies composed mainly of refractory rocky and metallic minerals, with some ice. Asteroids range in size from hundreds of kilometers across to microscopic. All asteroids except the largest, scie3, are classified as small solar system bodies. Question 4. Q. Match list I with list 2 and select the correct answer by using the codes given below the lists. 1998. List I. Special characteristic. List 2. Name of planet. A. Smallest planet of the solar system 1. Mercury. B. Largest planet of the solar system 2. Venus. C. Planet second from the sun in the solar system 3. Jupiter. D. Planet nearest to the sun 4. 2 to 5. Saturn. Codes. A. A2. B3. C5. D1. B. A3. B5. C1. D2. C. A4. B1. C2. D3. D. A4. B3. C2. D1. Answer D. Question 5. Q. A meteorus 1995. A rapidly moving star. B. A piece of matter which has entered the Earth's atmosphere from outer space. C. Part of a constellation. D. A comet without a tail. Answer B. Explanation. Meteor. Any solid debris originating from asteroids or comets or from outer space that falls to the Earth, the Moon, or another planet in the solar system is called a meteor. It travels at a great speed through space and becomes luminous when enters into the atmosphere because it is heated by friction. Meteorite. Many meteors burn out completely while traveling through the atmosphere because of frictional heat. Therefore, they do not reach the surface of the planet or the Moon. Some meteors do not completely burn out and strike the surface of the planet or the Moon. They are called meteorites. Question 6. Q. Which one of the following statements is correct with reference to our solar system? 2002. A. The Earth is the densest of all the planets in our solar system. B. The predominant element in the composition of Earth is silicon. C. The Sun contains 75% of the mass of the solar system. D. The diameter of the Sun is 190 times that of the Earth. Answer A. Explanation. Some important facts. Question 7. Q. Among the following which planet takes maximum time for one revolution around the Sun? 2003. A. Earth. B. Jupiter. C. Mars. D. Venus. Answer B. EXPLANETOIN. Planet. Rotation period Earth days. Revolution period Earth years. Mercury 58.6 days 88 days, Venus 243 days 224.7 days, Earth 1 day 365 days, Mars 1.03 days 1.88 years, Jupiter 0.41 days 11.86 years, Saturn 0.45 days 29.5 years, Uranus 0.72 days 84 years, Neptune 0.67 days 165 years, Pluto 6.39 days 248.5 years. Question 8. Q. What is the average distance approximate between the Sun and the Earth? 2007. A. 70 times 105 km. B. 100 times 105 km. C. 110 times 106 km. D. 150 times 106 km. Answer D. Explanation. Important definition: light year. Distance covered by light in 1 year in vacuum at a speed of 3 by 108 meters per second. 1 light year is equal to 9.46 times 1012 kilometers. Astronomical unit. Mean distance between the Sun and the Earth 1.49 by 108 kilometers. 1 light year is equal to 60,000 astronomical units. Question 9. Q. In order of their distances from the Sun, which of the following planets lie between Mars and Uranus? 2008. A. Earth and Jupiter. B. Jupiter and Saturn. C. Saturn and Earth. D. Saturn and Neptune. Answer B. Explanation. The order of planets. Question 10. Q. Which one of the following planets has largest number of natural satellites or moons? 2009. A. Jupiter. B. Mars. C. Saturn. D. Venus. Answer A. Explanation. Moon in the solar system. Planets. Dwarf planets. Planet moons. Dwarf planet moons. Mercury 0, Pluto 5, Venus 0, make 1, Earth 1, Ceres 0, Mars 2, Haumi 2, Jupiter 79, Eris 1, Saturn 62. Uranus 27. Neptune 14. Total 185 9. Do it yourself. Q. Which one of the following stars is nearest to the Earth? 1997. A. Polaris. B. Alpha Centauri. C. Sun. D. Sirius. Geomorphology. Earth and its evolution. Question 11. Q. Which one of the following scholars suggested the Earth's origin from gases and dust particles? 1999. A. James Jeans. B. H. Alfman. C. F. Hoyle. D. O. Schmidt. Answer D. Explanation. Universe. Earth is the third planet from the Sun and is the largest of the terrestrial planets. Age of the Earth is estimated to be around 4.5 billion years. The formation of Earth is linked to the formation of the solar system and various theories have been proposed to explain it. Theories to explain origin of Earth nebula hypothesis. Given by Immanuel Kant and further revised by Laplace in 1796. Planets were formed out of a slowly rotating cloud of gas and dust called a nebula. The nebula cooled gradually and contracted, shelling out rings of gases and dust. Later, the rings cooled and accumulated to form planets, one of them being Earth. The central region became Sun. Planet-Simal hypothesis. Chamberlain and Moulton proposed the theory in 1904. The Sun existed before the formation of planets. Another star came close to the Sun. Because of the gravitation pull of the star, small gaseous bodies were separated from the Sun. These bodies on cooling became small planets called as planet-simals. During rotation, the planet-simals collided and formed planets. Gaseous tidal theory. James Jeans and Jeffrey proposed the theory in 1925. Large star came near the Sun. Due to gravitational pull, a gaseous tide was raised on the surface of the Sun. As the star came nearer, the tide increased in size. Gaseous tide detached when star moved away. The shape of the tide was like spindle. It broke into pieces, forming 9 planets of the solar system. Objections with the above theories. Sun should have the greatest angular momentum in the solar system because of its mass. 2. Position in the center. However, the Sun has only 2% of momentum of the solar system. Couldn't explain the large interplanetary distances. The Sun and the planets are made up of different elements. Interstellar dust theory. In 1950, Otto Schmidt revised the nebula hypothesis, though differing in details. He considered that the Sun was surrounded by solar nebulae containing mostly the hydrogen and helium along with what may be termed as dust. The friction and collision of particles led to formation of a disc-shaped cloud and the planets were formed through the process of accretion. Question 12. Q. Who amongst the following was the first to state that the Earth was spherical? 2001. A. Aristotle. B. Copernicus. C. Ptolemy. D. Strabo. Answer A. Explanation. Early astronomers and philosophers on the shape of Earth. A star is a luminous sphere of plasma held together by its own gravity. Aristotle. First gave reasons for the spherical shape of Earth in around 4th century BC. Aristotelians. First scientifically measured the size of the Earth to a significant degree of accuracy around 240 BC. Ptolemy. First to use grid system to make maps in his work Geographia, 2nd century AD. Strabo. Suggested the spherical shape of Earth based on the experiences on sailors. Around 1st century AD. Copernicus. Gave the concept of heliocentric universe in 16th century. Question 13. Q. Consider the following pairs, 2039. 1. Electromagnetic radiation. 2. Geothermal energy. 3. Gravitational force. 4. Plate movements. 5. Rotation of the Earth. 6. Revolution of the Earth. Which of the above are responsible for bringing dynamic changes on the surface of the Earth? 1, 2, 3 and 4 only. B. 1, 3, 5 and 6 only. C. 2, 4, 5 and 6 only. D. 1, 2, 3, 4, 5 and 6. Answer D. Explanation. Electromagnetic radiation. Radiation from sun in form of visible light, infrared, UV, etc. have profound dynamic effects resulting into day and night, warmth, movement of air, winds, water, ocean currents, cloud formation, evaporation. Electromagnetic radiation. Energy from inside the Earth bring dynamic change on the surfaces, volcanoes, hot springs, plate movements, gravitational force. One of the strongest forces on the surface. Effects like landslides, waterfalls, avalanches, rainfall, snowfall, etc. Plate movements. They usually have slow and unnoticeable effects on the surface, but some dynamic and catastrophic effects are also caused like earthquakes, tsunamis, folding, mountain building, rotation of the Earth. Dynamic effects include day and nights. Coriolis force acts on all moving objects, seasons, because of rotation on tilted axis. Revolution of the Earth. Revolution around the sun in combination with rotation helps in causing seasons. Temperature differences, aphelion and perihelion. Question 14. QQ. Consider the following statements. 2005. 1. Total land area of Earth is approximately 1475 lakh square kilometers. 2. Ratio of land area to water area of Earth is approximately 1, 4. 3. Maximum percentage of Earth's water is in the Pacific Ocean. Which of the statements given above are correct? 1 and 3, B, 2 and 3, C, 1 only, D, 3 only. Answer A. Explanation. Some important facts. Fifth largest planet in the solar system. Blue planet. From the outer space, the Earth appears blue because its 2/3 surface is covered by water. Distance from Sun, 149 million km, 147.5 at perihelion closest to the Sun, 152.2 at aphelion farthest from the Sun. Shape, geoid, oblate, spheroid, slightly flattened at the poles and bulging at the equator. Approximate equatorial circumference 40,000 kilometers. Surface area, 510 million kilometers to land area, 148.9 million kilometers to ratio of land to water, 3, 7, NH2, 3, SH1, 4. Speed of rotation around axis 1600 kilometers per hour. The equator decreases poleward. Average temperature, around 14 OC. Moderate temperature, neither too far nor too close to the Sun. Goldilocks zone. Water can exist in liquid state. Question 15. Q. Variations in the length of daytime and nighttime from season to season are due to 2013. A. The Earth's rotation on its axis. B. The Earth's revolution round the Sun in an elliptical manner. C. Latitudinal position of the place. D. Revolution of the Earth on a tilted axis. Answer. D. Explanation. Motions of the Earth rotation. Rotates around its axis from west to east. Causes the day-night cycle. Objections with the above theories. Solar day. Time taken to complete one rotation, i.e. approximately 24 hours. Speed of rotation decreases from equator to polewards. Objections with the above theories. The axis of rotation is inclined with an angle of 23.5 resulting in varying length of days and nights in different seasons. Motions of the Earth revolution. Earth revolves around the Sun in an elliptical orbit. Objections with the above theories. Time taken is about 365 days and 6 hours to complete one revolution. The extra 6 hours become one extra day in a leap year after 4 revolutions. Objections with the above theories. Earth is closest to the Sun on the 3rd of January, 147 million kilometers, called as perihelion. Earth is farthest from the Sun on the 4th of July, 153 million kilometers, called as aphelion. Seasons. Seasons are the result of the inclination of the Earth's rotational axis. Seasons. Seasons are the result of the inclination of the Earth's rotational axis. Important terms. Equinox. The Sun shines directly over equator, equal lengths of day and night. Vernal equinox, spring equinox, the 21st of March, spring, autumn, in northern, southern hemisphere. Autumn equinox, the 23rd of September, autumn, spring, in northern, southern hemisphere. Solstice. The Sun shines directly over one of the tropics. Summer solstice, the 21st of June, Sun is over Tropic of Cancer, summer, winter, in northern, southern hemisphere. Winter solstice, the 22nd of December, Sun is over Tropic of Capricorn, winter, summer, in northern, southern hemisphere. Are days always longer than nights at the equator? Question 16. Q. If the stars are seen to rise perpendicular to the horizon by an observer, he is located on the 2001. A. Equator. B. Tropic of Cancer. C. South Pole. D. North Pole. Answer. A. EXPLANATOIN. Latitudes. Imaginary east-west running parallel lines on the globe. Imaginary circles with unequal diameter. Measured in degrees, 1 degree equals 60 minutes equals 3600 seconds. There are 181 latitudes in total. Longest latitude, equator, 0, divides Earth into two hemispheres, i.e. north and south hemisphere. At poles, 90 N and 90 S shrink to a point. Important latitudes. Tropic of Cancer, 23.5 N, Tropic of Capricorn, 23.5 S, Arctic Circle, 66.6 N, Antarctic Circle, 66.5 S. Longitudes. Imaginary lines extending from pole to pole. Are semicircles and the distance between them decreases polewards. All longitudes converge at the poles. There are 360 longitudes in total. The prime meridian, 0, is chosen as a reference line dividing the globe into western and eastern hemispheres. International date line, 180 longitude is chosen as international date line. The west side of the line is always one day ahead of the eastern side. Celestial equator. An imaginary circle around the sky directly above the Earth's equator. It is always 90 degrees from the poles. All the stars rotate in a path that is parallel to the celestial equator. The celestial equator intercepts the horizon at the points directly east and west anywhere on the Earth. Stars rise perpendicular to horizon at the equator and rotate parallel to horizon at the poles. Question 17. Q. In the Earth's direction of rotation is reversed, what should be the IST when it is noon at the international date line? 1997. A. O 6.30 hours. B. O 5.30 hours. C. 18.30 hours. D. 17.30 hours. Answer. C. Explanation. Longitudes and times. Because one day is 24 hours long, one can easily use time to calculate longitude. 1 hour of time difference corresponds to 15 degrees of longitude, 360 degrees, 24 hours equals 15 degrees per hour. Indian Standard Time. Indian Standard Time is 5:30 hours ahead of Coordinated Universal Time, UTC, based on 82.50 east longitude. It means that when it is 12 noon at Greenwich, 0 O longitude, and 12 am at international date line, 180 O longitude, time in India is 5:30 pm. Time difference measured from Greenwich equals plus 5:30 hours. Time difference measured from international date line equals 12 to 5:30 equals 6:30 hours. So if it is 12 pm at international date line and direction of rotation is reversed, sign before difference turns from negative to positive, then time difference is plus 6:30 hours. Question 18. Q. Consider the following statements. 2005. 1. The axis of the Earth's magnetic field is inclined at 23.5 to the geographic axis of the Earth. 2. The Earth's magnetic pole in the northern hemisphere is located on a peninsula in northern Canada. 3. The Earth's magnetic equator passes through Tumba in South India. Which of the statements given above are correct? A. 1, 2 and 3 B, 2 and 3 C, 2 only D, 3 only. Answer B. Explanation. Earth's magnetic field. It is also known as geomagnetic field. Approximately, it is the field of a magnetic dipole currently tilted at an angle of about 11 degrees with respect to Earth's rotational axis, as if there were a bar magnet placed at that angle at the center of the Earth. Cause of Earth's magnetic field. The magnetic field of the Earth is generated by the motion of molten iron alloys in the Earth's outer core. Differences in temperature, pressure and composition within the core cause convection currents in the molten metal. This flow of liquid iron generates electric currents, which in turn produce magnetic fields. This effect is known as dynamo effect. Geomagnetic reversal. A geomagnetic reversal is a change in a planet's magnetic fields if the positions of magnetic north and magnetic south are interchanged. This happens in a cycle of a few 100,000 years. Some important terms. Intensity of magnetic field. Depicts the strength of the geomagnetic field. The intensity of the geomagnetic field is greatest near the poles and weaker near the equator. Magnetic deep. Magnetic deep or magnetic inclination is the angle made with the horizontal by the compass needle of a vertically held compass. The deep angle decreases uniformly from 90 at the magnetic poles to 0 at the magnetic equator. Magnetic equator. The irregular imaginary line passing round the Earth near the equator, on which a magnetic needle has no deep. It passes through Tumba, Kerala. Magnetic North Pole. The North Magnetic Pole is the wandering point on the surface of Earth's northern hemisphere at which the planet's magnetic field points vertically downwards. The North Magnetic Pole moves over time due to magnetic changes in the Earth's core. In 2001, it was determined by the Geological Survey of Canada to lie west of Ellesmere Island in northern Canada was moving toward Russia at between 55 and 60 kilometers, 34 and 37 miles per year. Magnetic South Pole. The south magnetic pole is the wandering point on the Earth's southern hemisphere where the geomagnetic field lines are directed vertically upwards. It is located in Antarctica. Advantages of Earth's magnetic field. This field acts as a shield that blocks the solar winds emanating from the sun. This wind consists of energetically charged particles which can severely damage the life on the planet. However, some particles manage to enter our planet, being directed by the magnetic field towards the poles, causing those amazing lights known as polar lights. Helps in navigation by use of compass. Magnetoperception. Some animals can use this magnetic field to navigate while migrating over long distances. Question 19. Q. Diamond ring is a phenomenon observed. 1996. A. At the start of a total solar eclipse. B. At the end of a total solar eclipse. C. Only along the peripheral regions of the totality trail. D. Only in the central regions of the totality trail. Answer C. Explanation. Eclipse. It is defined as an astronomical phenomenon which occurs when one spatial object comes within the shadow of another spatial object. It happens when three celestial bodies are in a straight line. This alignment of three celestial objects in a straight line is known as a syzygy. Solar eclipse. As observed from the Earth, a solar eclipse occurs when the moon passes in front of the sun. This occurs on a new moon phase. Depending on the distance of the moon from the Earth during the event, different types of solar concealment can be observed. They can be categorized as partial, only a portion of sunlight is blocked. Annular, sun can be seen around the edges like a bright ring. Total, sun is completely blocked by the moon. Lunar eclipse. Lunar eclipses occur when the moon passes through the Earth's shadow. This happens only during a full moon, when the moon is on the far side of the Earth from the sun. Depending on how the sun, the moon, and the Earth line up, lunar eclipse too can be categorized as partial, when only a part of the moon moves into the shadow of the Earth. Total, when the Earth passes directly in front of the moon and casts its shadow on the full moon. Find out the meaning of following terms. Blood moon, blue moon, supermoon. Question 20. Q. Assertion A. The same phase of the moon is always presented to the Earth. Reason R. The moon rotates about its own axis in 23.5 days, which is about the same time that it takes to orbit the Earth. Choose the appropriate quotes from below. 2005. Both A and R are true and R is the correct explanation of A. B. Both A and R are true but R is not a correct explanation of A. C. A is true but R is false. D. A is false but R is true. Answer. C. Explanation. Orbit of the moon. As the moon orbits around the Earth, the half of the moon that faces the sun will be lit up. The same half of the moon always faces the Earth because of tidal locking. A tidally locked body takes just as long to rotate around its own axis as it does to revolve around its partner. This makes one hemisphere constantly face the partner body. The moon rotates about its own axis in 27 days, which is about the same time that it takes to orbit the Earth. The different shapes of the lit portion of the moon that can be seen from Earth are known as phases of the moon. Find out. Why do solar eclipses happen only on new moon day? Why do lunar eclipses happen only on full moon day? Question 21. Q. Which of the following phenomena might have influenced the evolution of organisms? 2014. 1. Continental drift. 2. Glacial cycles. Select the correct answer using the code given below. 1 only. B. 2 only. C. Both 1 and 2. D. Neither 1 nor 2. Answer C. Explanation. Continental drift theory. Given by Alfred Wegener, The Origin of Continents and Oceans, 1915, to explain the present arrangement of continents and oceans. All the continents form a single continental mass, Pangaea, and a mega ocean, Punthalassa, surrounded it. Around 200 million years ago, the supercontinent, Pangaea, began to split. Pangaea first broke into two large continental masses as Laurasia, unvirulent, northern part, consisting of North America, Greenland and Eurasia, without Arabia and India, traveled northwards. Gondwanulent, southern part, contained Africa, Arabia, South America, Australia, Antarctica and India and traveled southwards. Timescale of continental drift. Evidences of continental drift theory. Jigsaw fit of coastlines. Shorelines of Africa and South America facing each other have a remarkable and unmistakable match. Rocks of the same age across the oceans. The belt of ancient rocks, 2 billion years old, from Brazil coast matches with those from Western Africa. The earliest marine deposits along the coastline of South America and Africa are of the Jurassic Age. This suggests that the ocean did not exist prior to that time. Evidences of continental drift theory. Fossil distribution. Identical species of plants and animals adapted to living on land or in fresh water are found on either side of marine barriers. Glacial tillet. It is the sedimentary rock formed out of deposits of glaciers. Global cycle. Global period. A glacial period is an interval of time, thousands of years, within an ice age that is marked by colder temperatures and glacier advances. The last glacial period was the most recent glacial period within the Quaternary Ice Age, occurring in the Pleistocene epoch, which began about 110,000 years ago and ended about 15,000 years ago. Interglacial period. Interglacials, on the other hand, are periods of warmer climate between glacial periods. The Holocene epoch is the current interglacial. A time when there are no glaciers on Earth is considered a greenhouse climate state. Question 22. Q. Which one of the following conditions is most relevant for the presence of life on Mars? 1997. Atmospheric composition. B. Thermal conditions. C. Occurrence of ice caps and frozen water. D. Occurrence of ozone. Answer. C. Question 23. Q. Consider the following statements. 2008. 1. Albedo of an object determines its visual brightness when viewed with reflected light. 2. Albedo of Mercury is much greater than the albedo of the Earth. Which of the statements given above are correct? 1 only. B. 2 only. C. Both 1 and 2. D. Neither 1 nor 2. Answer. C. Explanation. Albedo. Albedo is a measurement of the amount of light reflected from the surface of a celestial object, such as a planet, satellite, comet or asteroid. The albedo is the ratio of the reflected light to the incident light. It is dimensionless and measured on a scale from 0, corresponding to a black body that absorbs all incident radiation, to 1 corresponding to a body that reflects all incident radiation. Planets and satellites with clouds tend to have a high albedo, while rocky objects such as asteroids have a low albedo. The albedo of an object changes with wavelength, depending on the efficiency of reflection for different parts of the electromagnetic spectrum. Albedo of celestial bodies. Planet albedo. Mercury 0.12, Venus 0.75, Earth 0.30, Moon 0.12. Mars 0.16, Jupiter 0.34, Saturn 0.34, Uranus 0.30, Neptune 0.29, Pluto 0.4. Question 23. Q. Consider the following statements. 2008. 1. Albedo of an object determines its visual brightness when viewed with reflected light. 2. Albedo of Mercury is much greater than the albedo of the Earth. Which of the statements given above are correct? A. 1 only. B. 2 only. C. Both 1 and 2. D. Neither 1 nor 2. Answer A. Question 24. Q. Consider the following statements. 1. The Earth's magnetic field has reversed every few 100,000 years. 2. When the Earth was created more than 4,000 million years ago, there was 54% oxygen and no carbon dioxide. 3. When living organisms originated, they modified the early atmosphere of the Earth. Which of the statements given above are correct? 2018. C. 1 only. D. 2 and 3 only. C. 1 and 3 only. D. 1, 2 and 3. Answer C. Evolution of Earth. Evolution of. The Earth was mainly in a volatile state in its primordial stage. Due to gradual increase in density, temperature inside increased. This caused the material inside to separate according to their densities. As a result, heavier materials like iron and nickel sank towards the center of the Earth, while the lighter ones like silicon and aluminium moved towards the surface. Process of differentiation. With the passage of time, it further cooled, solidified and condensed into a smaller size. This later led to the formation of the outer surface in the form of the crust. During the formation of the Moon, due to the giant impact, the Earth was further heated up again. The process of differentiation led the Earth forming materials to separate into different layers of varying densities. Question 25. Q. Assertion A. To orbit around the Sun, the planet mass takes lesser time than the time taken by the Earth. Evolution of Earth. Evolution of. First stage, loss of primordial atmosphere. The early atmosphere, with hydrogen and helium, is supposed to have been stripped off as a result of solar winds. This happened for all terrestrial planets. Second stage, contribution of the hot interior of the Earth. During the cooling of the Earth, gases and water vapor were released from the interior solid Earth, which started the evolution of the present atmosphere. The early atmosphere largely contained water vapor, nitrogen, carbon dioxide, methane, ammonia, and very little of free oxygen. The process through which the gases were outpouring from the interior of the Earth is called degassing. Continuous volcanic eruptions contributed water vapor and gases into the atmosphere. Evolution of Earth. Evolution of. As the Earth cooled, the water vapor released started getting condensed. The carbon dioxide in the atmosphere got dissolved in rainwater, and the temperature further decreased, causing more condensation and more rain. The falling rainwater got collected in depressions, giving rise to oceans. The Earth's oceans were formed within 500 million years from the formation of the Earth. Therefore, the oceans are 4 billion years old. Modification via photosynthesis. Around 3.8 billion years before present, DYBP, life began to evolve, and around 2.5-3 BYBP, the process of photosynthesis got evolved. Eventually, the oceans got saturated with oxygen, and around 2 BYBP, oxygen began to flood the atmosphere. Reason R. The diameter of the planet mass is less than that of Earth. Codes. 2006. Both A and R are individually true, and R is the correct explanation of A. B. Both A and R are individually true, but R is not the correct explanation of A. C. A is true, but R is false. D. A is false, but R is true. Answer D. Do it yourself. Question 25. Q. Assertion A. Existence of human life on Venus is highly improbable. Reason R. Venus has extremely high level of carbon dioxide in its atmosphere. Codes. 2006. Both A and R are true, and R is the correct explanation of A. B. Both A and R are true, but R is not the correct explanation of A. C. A is true, but R is false. D. A is false, but R is true. Geomorphology, Earth's interior, volcanism, rocks and WEATHERING. Question 26. Q. In the structure of planet Earth, below the mantle, the core is mainly made up of which one of the following? 2009. A. Aluminium. B. Chromium. C. Iron. D. Silicon. Answer C. Explanation. Interior of the Earth. The structure of the Earth's interior is made up of several concentric layers. Broadly, 3 layers can be identified: crust, mantle, core. The crust. Crust is the outer thin layer with a total thickness normally between 30 to 50 km. Oceanic crust is thinner, 5-30 km, than the continental crust, 50-70 km. The continental crust is thicker in the areas of major mountain systems. It is as much as 70-100 km thick in the Himalayan region. It forms 0.5-1.0% of the Earth's volume. The outer covering of the crust is of sedimentary material, granitic rocks, and below that lie crystalline, igneous and metamorphic rocks which are acidic in nature. The lower layer of the crust consists of basaltic and ultra-basic rocks. The continents are composed of lighter silicates, silica plus aluminium, also called Cl, while the oceans have the heavier silicates, silica plus magnesium, also called Sima. The core lies between 2,900 km and 6,400 km below Earth's surface. Accounts for 16% of the Earth's volume. Core has the heaviest mineral materials of highest density. It is composed of nickel and iron, BiF. The outer core is liquid while the inner core is solid. Their boundary is Lehman discontinuity. Chemical and physical. Composition. Sources of information about the interior: direct sources. Surface rocks. Deep earth mining and drilling. Volcanic eruptions. Indirect sources. Geomagnetism. Seismic activity. Meteors. Temperature and density variations. Indirect sources: meteors. Material that becomes available for analysis from meteors is not from the interior of the Earth, although it is similar or same in some respects like structure and material. Magnetic field. Magnetic surveys provide information about the distribution of magnetic materials in Earth's interior. Gravitational anomalies. Gravitational anomalies, variations in recorded gravity values, indicate the layered structure and unequal distribution of the mass of material in the Earth's interior. Seismic waves. The study of seismic waves provides a complete picture of the layered interior. Abrupt release of energy along a fault causes earthquake. This causes a release of energy, and the energy waves travel in all directions. The point where the energy is released is called the focus or hypocenter of an earthquake. The energy waves traveling in different directions reach the surface. Earthquake waves are basically of two types. Body waves are generated due to the release of energy at the focus and move in all directions, traveling through the body of the Earth. Surface waves. The body waves interact with the surface rocks and generate new set of waves called surface waves. These waves move along the surface. The velocity of waves changes as they travel through materials with different elasticity, stiffness, or density. The more elastic the material is, the higher is the velocity. Their direction also changes as they reflect or refract when coming across materials with different densities. Question 27. Q. Consider the following statements. 2006. 1. The Richter scale is a logarithmic scale and so an increase of 1 magnitude unit represents a factor of 10 times in amplitude. 2. Each integer reading of the Richter scale has an energy 100 times the previous integer reading. Which of the statements given above are correct? A. 1 only. B. 2 only. C. Both 1 and 2. D. Neither 1 nor 2. Answer A. Explanation. Earthquakes. A vibration or oscillation of the surface of the earth caused by elasticity or isostatic adjustment of rocks beneath the surface. It is a release of energy in form of seismic waves deep beneath the crust. Seismograph is the instrument used to record the earthquake waves. The source of the quake is called the focus. The point on the surface directly above the focus is called epicenter. Plate tectonic theory has been accepted as the most plausible explanation of the causes of the earthquakes. Disequilibrium is caused due to different types of plate motions and consequently earthquakes of varying magnitudes occur. 2. Body waves. Primary peak waves. Also called as the longitudinal or compressional waves, i.e. particles of the medium vibrate along the direction of propagation of the wave. P waves move faster and are the first to arrive at the surface. These waves are of high frequency and they can travel in all mediums. Velocity of P waves in solids greater than liquids greater than gases. Their velocity depends on shear strength or elasticity of the material. Primary peak waves. Also called as transverse or distortional waves, analogous to water ripples or light waves. S waves arrive at the surface with some time lag. These waves are of high frequency waves which cannot pass through liquids or gases. This observation led to the discovery of liquid outer core. Since S waves cannot travel through liquid, they do not pass through the liquid outer core. Surface waves. Also called as long period waves. They are low frequency, long wavelength, and transverse vibration. Generally affect the surface of the earth only and die out at smaller depth. Develop in the immediate neighborhood of the epicenter. They cause displacement of rocks and hence the collapse of structures occurs. These waves are responsible for most of the destructive force of earthquake. Recorded last on the seismograph. Types of earthquakes. Tectonic earthquake, due to rock movement along a fault line. Volcanic earthquake, these occur near the area of an active volcano. Collapse earthquake, occur in the area of intense mining. Explosive earthquake, due to explosion of underground explosives or nuclear weapons. Reservoir-induced earthquake, due to huge weight of reservoir water. How are earthquakes measured? Richter scale. The Richter magnitude scale is a scale of numbers used to tell the size, energy released of earthquakes. Charles Richter developed the Richter scale in 1935. It is logarithmic scale, i.e. with each integer increase in scale, the amplitude increases by a factor of 10 and energy increases by a factor of 32. Michelli scale. Measures the intensity of earthquake or the effects felt because of it. Giuseppe Michelli developed the Richter scale in 1902 and it was modified later. It measures earthquakes on a scale of 12 ranging from instrumental, detected only by instruments, to catastrophic. Question 28. Q. Volcanic eruptions do not occur in 2001. A. Baltic Sea. B. Black Sea. C. Caribbean Sea. D. Caspian Sea. Answer A. Explanation. Which is a vaccine? A volcano is an opening in the earth's crust through which molten material, gases as well as pyroclastic materials erupt. Classifications of volcanoes. Active volcanoes, frequent eruptions, Egg Mount. Erebus, Antarctica, Mount. Stromboli, Italy. Dormant volcanoes, no recent activity, Egg Mount. Kilimanjaro, Tanzania, Mauna Kea, Hawaii. Extinct volcanoes, active in distant geological past but no indications of future volcanicity. Egg Mount. Chimborazo, Ecuador. Find out more about the different categories of earthquakes according to Michelli scale. Find out the differences between Richter and Michelli scale. Causes for volcanism. Plate tectonic theory. In 1967, Mackenzie and Parker suggested the theory of plate tectonics. The theory was later outlined by Morgan in 1968. According to this theory, Earth's lithosphere is broken into distinct plates which are floating on a plastic layer called asthenosphere, upper mantle. Plates move horizontally over the asthenosphere as rigid units. Plate movements. Major geomorphological features such as fold and block mountains, mid-oceanic ridges, trenches, volcanism, earthquakes, etc. are a direct consequence of interaction between various lithospheric plates. Causes for volcanism. Divergent plate boundary, constructive boundary. Mid-oceanic ridges, seafloor spreading, sites of earth crust formation, hence constructive and volcanic earth forms are common along such edges. Earthquakes, shallow focus, are common. Examples, East African Rift Valley, due to divergence of African and Somali plates, Mid-Atlantic Ridge, American plates are separated from the Eurasian and African plates. Causes for volcanism. Plate movements. Convergent plate boundary, destructive boundary. Plates collide against each other. The zone of collision may undergo crumpling and folded mountains may emerge. This is an orogenic collision. E.g., Himalayan boundary fault. When one of the plates is an oceanic plate, it gets embedded in the softer asthenosphere of the continental plate and as a result, trenches are formed at the zone of subduction. The subducted material gets heated up and is thrown out forming volcanic islands. Thus, there are mainly three ways in which convergence can occur. Between an oceanic and continental plate. Between two oceanic plates and between two continental plates. Causes for volcanism. Transform fault boundary, conservative boundary. Formed when two plates slide past each other. In this kind of interaction, two plates grind against each other and there is no creation or destruction of landform. Crust is neither produced nor destroyed as the plates slide horizontally past each other. In oceans, transform faults are the planes of separation generally perpendicular to the mid-oceanic ridges. San Andreas Fault along the western coast of USA is the best example for a transform edge on continents. Active volcanic regions. Do it yourself. Q. Where is the volcanic mountain, Mount St. Helens located? 2005. A. Atmospheric composition. F. Thermal conditions. G. Occurrence of ice caps and frozen water. H. Occurrence of ozone. Answer. C. Question 29. Q. Consider the following statements. 2018. 1. The Barren Island volcano is an active volcano located in the Indian territory. 2. Barren Island lies about 140 kilometers east of Great Nicobar. 3. The last time the Barren Island volcano erupted was in 1991 and it has remained inactive since then. Which of the statements given above are correct? 1 only, B, 2 and 3, C, 3 only, D, 1 and 3. Answer A. Explanation. Volcano in India. Barren Island is the only live volcano in the Indian territory. The Barren Island volcano is located 140 kilometers northeast of Port Blair. It had been dormant for more than 150 years before it started erupting in 1991 and has since then shown intermittent activity. Question 30. Q. Consider the following statements made about sedimentary rocks. 2001. 1. Sedimentary rocks are formed at Earth's surface by the hydrological system. 2. Formation of sedimentary rocks involves the weathering of pre-existing rocks. 3. Sedimentary rocks contain fossils. 4. Sedimentary rocks typically occur in layers. Which of these statements are correct? 1 and 2, B, 1 and 4, C, 2, 3 and 4, D, 1, 2, 3 and 4, answer, D. Explanation. Rocks. Any naturally occurring organic or inorganic substances having an orderly atomic structure and definite chemical composition and physical properties. Any naturally occurring agglomeration of mineral particles forms a rock. On the basis of mode of origin, rocks are classified as igneous, sedimentary, metamorphic, igneous rocks, formed after the cooling and solidification of molten lava coming out of the Earth's interior. These are granular and crystalline rocks. Are also known as primary or basic rocks, as these are the first rocks to be formed. Examples: granite, basalt, peridotite, etc. Classification of igneous rocks. On the basis of mode of occurrence, igneous rocks are further classified as intrusive or plutonic rocks. Cooling has been deep-seated. Egg, granite, diorite, etc. Extrusive rocks. Cooling and solidification at shallow depth or at surface. Egg, basalt, rhyolite. Sedimentary rocks. Rocks formed on the surface due to deposition and lithification of eroded material of igneous and sedimentary rocks. These occur in layers or beds. Found over 95% of the crust but contribute only 5% in the crustal volume. These also contain fossils which are absent in igneous and metamorphic rocks. Classification of sedimentary rocks. Sedimentary rocks are further classified as mechanically formed or plastic rocks, sandstones, conglomerates, loess, etc. Chemically formed rocks such as chalk, gypsum, salt rocks, etc. Biologically formed rocks such as limestone, coal, peat, etc. Shale, limestone and sandstone make up over 99% of all sedimentary rocks. Classification of igneous rocks. Shale. Formed due to complete alteration in the appearance and the composition of pre-existing igneous or sedimentary rocks due to change in temperature and pressure. Are the hardest rocks and devoid of fossils. Metamorphism usually takes place at depth in roots of mountains or adjacent to intrusive igneous rocks. Examples: slate from shale, marble from limestone, quartzite from sandstone, gneiss, granite, schist, basalt, etc. Question 31. Q. Quartzite is metamorphosed from 2001. Limestone. B. Obsidian. C. Sandstone. D. Shale. Answer: C. Question 32. Q. Which one of the following types of coal contains a higher percentage of carbon than the rest? 1999. Bituminous coal. B. Lignite. C. Peat. D. Anthracite. Answer: D. Question 33. Q. Identify the correct order of the process of soil erosion from the following. 2001. Splash erosion, sheet erosion, rill erosion, gully erosion. B. Sheet erosion, splash erosion, gully erosion, rill erosion. C. Rill erosion, gully erosion, sheet erosion, splash erosion. D. Gully erosion, rill erosion, sheet erosion, splash erosion. Answer: A. Explanation. Denudation. The lowering and leveling of Earth's surface due to the action of exogenetic forces, like wind, running water, etc., is called denudation. Denudation plays a major role in shaping the landforms on the surface of the Earth. Denudation is influenced by following factors: relief or topography, climate, rock structure, actions of humans, erosion. Large-scale transportation of weathered materials by agents such as running water, wind, waves, etc. is termed as erosion. Erosional processes result in formation of various erosional and depositional landforms. Erosion results in loss of valuable topsoil which adversely impacts human activities like farming and construction, etc. Human activities may exaggerate the natural rate of topsoil erosion. Different stages of erosion by water. Splash erosion occurs when the raindrop hits the surface and impacts soil into individual particles. Sheet erosion is the detachment of soil particles by raindrop and their removal downslope by water flowing overland as a sheet in definite channels. Rill erosion refers to the development of small ephemeral concentrated flow paths which function as both sedimentary source and sediment delivery systems for erosion on hill slopes. When erosion occurs in lines which are more than 30 cm deep, then these forming channels are called as valley erosion. Splash erosion, rill erosion, sheet erosion, gully erosion. Geomorphology, atmosphere and TEMPERATURE. Question 34. Q. The correct sequence of different layers of the atmosphere from the surface of the Earth upwards is 1998. Troposphere, stratosphere, ionosphere, mesosphere. B. Stratosphere, troposphere, ionosphere, mesosphere. C. Troposphere, stratosphere, mesosphere, ionosphere. D. Stratosphere, troposphere, mesosphere, ionosphere. Answer: C. Explanation. The atmosphere. The atmosphere is a thick envelope of gases which surrounds the Earth bound by the force of gravity. Importance. Source of oxygen, carbon dioxide and other gases essential for life. It acts like a greenhouse and keeps Earth warmer and maintains an average temperature of 15 C throughout the surface. It prevents the incoming UV radiations. A storehouse for water vapor and facilitates the hydrological cycle along with various other chemobiological cycles such as nitrogen cycle, carbon cycle, etc. Propagation of sound and medium of flight. Composition of atmosphere. The atmosphere is a thick envelope of gases which surrounds the Earth bound by the force of gravity. CATEG. Cat. CA. Category name. Value. Cat. C. Composition of atmosphere. The atmosphere is classified into two zones on the basis of the chemical composition. Homosphere. The constituent gases are well mixed and the composition is homogeneous. Exist up to the altitude of about 50 miles 80 kilometers above mean sea level. Heterosphere. Lies above the homosphere and is a zone of poor mixing. Starts at 80 or minus 100 kilometers and coincides with the ionosphere and the thermosphere. Stratified arrangement of gases according to their molecular weight. Structure of atmosphere. The atmosphere has a layered structure with varying density and temperature. The density is highest near the surface of the Earth and decreases with increasing altitude. Layers of atmosphere. Troposphere. Stratosphere. Mesosphere. Thermosphere, ionosphere, exosphere. Question 35. Q. Which one of the following layers of the atmosphere is responsible for the deflection of radio waves? 1996. Troposphere. B. Stratosphere. C. Mesosphere. D. Ionosphere. Answer: D. Explanation. The troposphere. It is the lowest layer and almost all the weather phenomena occur here. It is a homogeneous layer because of constant movement mixing of air. Average height is 13 kilometers but varies with season, lower in winter, and latitude, up to 18 kilometers at equator and about 8 kilometers at poles. Temperature decreases with increasing height at rate of 6.5 C per 1000 meters. Tropopause separates troposphere from stratosphere. Contains about 75% of the total gaseous mass of the atmosphere. The atmosphere is a thick envelope of gases which surrounds the Earth bound by the force of gravity. The stratosphere. It extends from the tropopause to the height of 50 to 80 kms. The lower portion having maximum concentration of ozone is called ozonosphere, found between 15 to 35 kilometers. Height varies with the height of tropopause. The layer absorbs harmful ultraviolet rays from the sun. As a result, the temperature rises in this layer. This layer is free from atmospheric turbulences and is considered ideal for flight of jet aircrafts. The mesosphere lies above the stratosphere and extends up to the height of 80 kilometers. The temperature decreases with height and it falls from about 0 C at its base to about minus 100 C at the top. It is the coldest layer of the atmosphere. Its upper boundary is marked by the mesopause. The thermosphere lies beyond mesopause above 80 kilometers wherein temperature rises rapidly with increasing height. The high temperature, about 200 C at 350 kilometers, cannot be measured with ordinary thermometer due to extremely low density of the gases. Its lower portion is composed of nitrogen and oxygen in atomic forms. It is divided into two parts, ionosphere, exosphere. The ionosphere extends from 80 kilometers to 640 kilometers where ionized molecules of gases are found. There are a number of ionic layers in the sphere which form during days and vanish during nights. D layer, 60 to 90 kilometers, reflects low frequency radio waves and disappears with sunset. A layer, 99 to 130 kilometers, reflects medium and high frequency radio waves. The aurora lights are generated by this layer, Aurora australis in the south and Aurora borealis in the north. The exosphere. It represents the uppermost layer of the atmosphere. It extends beyond 640 kilometers. In this layer, the charged particles are concentrated in two bands at about 3,000 kilometers and 16,000 kilometers above the surface, as a result of trapping by the Earth's magnetic field called Van Allen radiation belt. Question 36. Q. A layer in the Earth's atmosphere called ionosphere facilitates radio communication. Why? 1. The presence of ozone causes the reflection of radio waves to Earth. 2. Radio waves have a very long wavelength. Which of the statements given above are correct? 2011 I. 1 only. B. 2 only. C. Both 1 and 2. D. Neither 1 nor 2. Answer B. Explanation. The electromagnetic spectrum. Question 37. Q. The jet aircrafts fly very easily and smoothly in the lower stratosphere. What could be the appropriate explanation? 1. There are no clouds or water vapor in the lower stratosphere. 2. There are no vertical winds in the lower stratosphere. Which of the statements given above are correct in this context? 2011 I. 1 only. B. 2 only. C. Both 1 and 2. D. Neither 1 nor 2. Answer C. Question 38. Q. Assertion A. Thickness of the atmosphere is maximum over the equator. Reason R. High insulation and strong convection currents occur over the equator. Codes. 2004. Both A and R are individually true and R is the correct explanation of A. B. Both A and R are individually true but R is not the correct explanation of A. C. A is true but R is false. D. A is false but R is true. Answer A. Explanation. The stratosphere. The atmosphere gets heated primarily from below through following ways. Radiation. Transfer of heat through the propagation of electromagnetic radiation. This process is the fastest and doesn't require any medium. E.g. insulation from sun. Convection. Transfer of heat by movement of a mass from one place to another, generally vertical. It occurs in liquids and gases. E.g. rising up of warm air. Convection. Heat flow from molecule to molecule due to their vibrational motion. It occurs between bodies in contact. E.g. convection of heat from the surface to the overlying air. Advection. Transfer of heat through horizontal movement of air. E.g. blowing of winds. Question 39. Q. Normally, the temperature decreases with the increase in height from the Earth's surface, because 2012 I. 1. The atmosphere can be heated upwards only from the Earth's surface. 2. There is more moisture in the upper atmosphere. 3. The air is less dense in the upper atmosphere. Select the correct answer using the codes given below. 1 only. B. 2 and 3 only. C. 1 and 3 only. D. 1, 2 and 3. Answer C. Explanation. Temperature in atmosphere. Question 40. Q. Assertion A. The amount of moisture in the atmosphere is related to latitude. Reason R. The capacity to hold moisture in the form of water vapor is related to temperature. Select the appropriate code. 2003. Both A and R are individually true and R is the correct explanation of A. B. Both A and R are individually true but R is not the correct explanation of A. C. A is true but R is false. D. A is false but R is true. Answer A. Explanation. Moisture in atmosphere. The ability of air to hold moisture is directly proportional to the temperature. Thus, higher temperature, high moisture. Temperature and latitudes. Question 41. Q. The annual range of temperature in the interior of the continents is highest compared to coastal areas. Which is are the reasons. 2039. 1. Thermal difference between land and water. 2. Variation in altitude between continents and oceans. 3. Presence of strong winds in the interior. 4. Heavy rains in the interiors compared to coasts. Select the correct answer using the codes given below. 1 only. B. 1 and 2 only. C. 2 and 3 only. D. 1, 2, 3 and 4. Answer A. Explanation. Range of temperature. Difference between highest and lowest temperature, i.e. total range along which temperature can vary. Land areas have a greater range of temperature than areas covered by water. Interior of continents, areas far from water bodies, have greater range of temperature than areas near water bodies. The ability of air to hold moisture is directly proportional to the temperature. Thermal difference between land and water. Land absorbs and releases heat faster than water. Thus, land areas exhibit greater difference between highest and lowest temperature. Water bodies have a moderating effect on temperature. Thus, coastal areas do not show a greater range of temperature. Question 42. Q. Consider the following statements. 2007. 1. Annual range of temperature is greater in the Pacific Ocean than that in the Atlantic Ocean. 2. Annual range of temperature is greater in the northern hemisphere than that in the southern hemisphere. Which of the statements given above are correct? 1 only. B. 2 only. C. Both 1 and 2. D. Neither 1 nor 2. Answer B. Question 43. Q. Which one of the following reflects back more sunlight as compared to other 3? 2010. Sand desert. B. Paddy crop. C. Land covered with fresh snow. D. Prairie land. Answer. C. Explanation. Albedo. Amount of light reflected back out of total light incident on a body. Sunlight reflected back. Sand desert 20.30%. Prairie grassland 25%. Land covered with fresh snow 85%. Paddy crop land 20 to 25%. Climatology, pressure belts and wind system. Question 44. Q. Consider the following statements. 2007. 1. Either of the two belts over the oceans at about 30 degrees to 35 degrees north and S latitudes is known as horse latitude. 2. Horse latitudes are low pressure belts. Which of the statements given above are correct? A. 1 only. B. 2 only. C. Both 1 and 2. D. Neither 1 nor 2. Answer. A. Explanation. The atmospheric pressure. The weight of a column of air contained in a unit area from the mean sea level to the top of the atmosphere is called the atmospheric pressure. It is measured by means of an instrument called barometer. The units used by meteorologists for this purpose are called millibars MB. Pressure belts. Run in east-west direction along certain specific latitudes. Total 7 pressure belts. Thermally induced belts, equatorial low. North polar high, south polar high. Dynamically induced belts, subtropical high, north, subtropical high, south, subpolar low, north, subpolar low, south. Equatorial low pressure belt formation. Due to intense heating, air gets warmed up and rises over the equatorial region, convection. Whenever there is vertically upward movement of air, the region of the surface will be at low pressure. Thus the belt along the equator is called equatorial low pressure belt. Climate. This belt is characterized by extremely low pressure with calm conditions. As the larger part of the low pressure belt passes along the oceans, the winds obtain huge amount of moisture. Vertical winds, convection, carrying moisture form cumulonimbus clouds and lead to thunderstorms, convectional rainfall. In spite of high temperatures, cyclones are not formed at the equator because of 0 Coriolis force. Subtropical high pressure belt formation. The air moving away from equatorial low pressure belt in the upper troposphere becomes dry and cold. This dry and cold wind subsides at 30 degrees north and S. So the high pressure along this belt is due to subsidence of air coming from the equatorial region which descends after becoming heavy. Climate. The subsiding air is warm and dry, therefore, most of the deserts are present along this belt in both hemispheres. A calm condition, anticyclonic, with feeble winds is created in this high pressure belt. The descending air currents feed the winds blowing towards adjoining low pressure belts. This belt is frequently invaded by tropical and extratropical disturbances. Polar high pressure belt formation. They lie around poles between 80 to 90 degree and NS latitudes. Extremely cold temperatures at the poles result in high pressure at the surface and cold air from the upper atmosphere subsides. Climate. The lowest temperatures are found over the poles. There is very little moisture in the air. Polar air is as dry as the air over driest deserts. Subpolar low pressure belt formation. Located between 45 degrees north and S latitudes and the Arctic and the Antarctic circles, 66.5 degrees north and S latitudes. These are dynamically produced due to Coriolis force produced by rotation of the Earth on its axis, and descent of air as a result of convergence of winds coming from polar and subtropical high. Owing to low temperatures in these latitudes, the subpolar low pressure belts are not very well pronounced year long. Such belts in the southern hemisphere are not as well differentiated. On long-term mean climatic maps, the subpolar low pressure belts of the northern hemisphere are grouped into two centers of atmospheric activity, the Iceland low and the Aleutian depression, Aleutian low. Climate. The area of contrast between cold and warm air masses produces polar jet streams which encircles the Earth at 60 degrees latitudes and is focused in these low pressure areas. Due to a great contrast between the temperatures of the winds from subtropical and polar source regions, extratropical cyclonic storms or lows, temperate cyclones or frontal cyclones are produced in this region. Question 45. Q. Consider the following statements. 2016 1. 1. The winds which blow between 30 degrees north and 60 degrees south latitudes throughout the year are known as westerlies. 2. The moist air masses that cause winter rains in northwestern region of India are part of westerlies. Which of the statements given above are correct? A. 1 only. B. 2 only. C. Both 1 and 2. D. Neither 1 nor 2. Answer. B. Explanation. Planetary winds formation. Winds blow in the same direction throughout the year covering the whole globe. These flow from high pressure belts to low pressure belts. They are classified into the trade winds, the westerlies, the polar easterly. Trade winds, tropical easterlies. These blow from subtropical high pressure areas towards the equatorial low pressure belt, confined to a region between 30 degrees north and 30 degrees south throughout the Earth's surface. They flow as the northeastern trades in the northern hemisphere and the southeastern trades in the southern hemisphere. The trade winds from two hemispheres meet at the equator, and due to convergence they rise and cause heavy rainfall. Westerlies. The westerlies are the winds blowing from the subtropical high pressure belts towards the subpolar low pressure belts. They blow from southwest to northeast in the northern hemisphere and northwest to southeast in the southern hemisphere. The westerlies of the southern hemisphere are stronger and persistent due to the vast expanse of water, while those of the northern hemisphere are irregular because of uneven relief of vast land masses. The westerlies are best developed between 40 degrees and 65 degrees S latitudes. These latitudes are often called roaring 40s, furious 50s, and shrieking 60s, dreaded terms for sailors. Polar easterlies. The polar easterlies are dry, cold prevailing winds blowing from northeast to southwest direction in northern hemisphere and southeast to northwest in southern hemisphere. They blow from the polar high pressure areas of the subpolar lows. These winds give birth to cyclones when they come in contact with westerlies. Western disturbance. Question 46. Q. What causes wind to deflect toward left in the southern hemisphere? 2010. A. Temperature. B. Magnetic field. C. Rotation of the Earth. D. Pressure. Answer. C. Explanation. Coriolis force. Due to this effect, winds in the northern hemisphere get deflected to the right of their path and those in the southern hemisphere to their left, following Farrell's law. This deflection force does not seem to exist until the air is set in motion and increases with wind velocity, air mass and an increase in latitude. The Coriolis force acts perpendicular to the pressure gradient force. Pressure gradient force is perpendicular to an isobar. The Coriolis force is directly proportional to the angle of latitude. It is maximum at the poles and is absent at the equator. Question 47. Q. Westerlies in southern hemisphere are stronger and persistent than in northern hemisphere. Why? 2011 I. 1. Southern hemisphere has less land masses compared to northern hemisphere. 2. Coriolis force is higher in southern hemispheres compared to northern hemisphere. Which of the statements given above are correct? A. 1 only. B. 2 only. C. Both 1 and 2. D. Neither 1 nor 2. Answer. A. Question 48. Q. Consider the following statements about the roaring 40s, 2000. 1. They blow uninterrupted in the northern and southern hemispheres. 2. They blow with great strength and constancy. 3. Their direction is generally from northwest to east in the southern hemisphere. 4. Overcast skies, rain and raw weather are generally associated with them. Which of these statements are correct? 1, 2 and 3, B, 2, 3 and 4, C, 1, 3 and 4, D, 1, 2 and 4, answer, B. Question 40. Q. Assertion A. 60 degrees 65 latitudes in both the hemispheres have a low pressure belt instead of high pressure. Reason R. The low pressure areas are permanent over oceans rather than on land. Select the correct code. 2002. Both A and R are true and R is the correct explanation of A. B. Both A and R are true but R is not the correct explanation of A. C. A is true but R is false. D. A is false but R is true. Answer, B. Question 50. Q. Assertion A. Areas near the equator receive rainfall throughout the year. Reason R. High temperatures and high humidity cause convectional rain in most afternoons near the equator. In the context of the above two statements, which one of the following is correct? 1996. Both A and R are true and R is the correct explanation of A. B. Both A and R are true but R is not the correct explanation of A. C. A is true but R is false. D. A is false but R is true. Answer, A. Question 51. Q. Which one of the following weather conditions is indicated by a sudden fall in barometer reading? 2001. Stormy. B. Calm weather. C. Cold and dry weather. D. Hot and sunny weather. Answer, A. Question 52. Q. Match list I with list 2 and select the correct answer using the codes given below the lists. 2001. List I. Local wind. List 2. Region. A. Fawn 1. Argentina. B. Sermon 2. Kurdistan. C. Santa Ana 3. California. D. Zone 4. Alps. Codes. A. A2. B4. C1. D3. B. A4. B2. C3. D1. C. A2. B4. C3. D1. D. A4. B2. C1. D3. Answer, B. Explanation. Local winds. Local differences of temperature and pressure produce local winds. Such winds are local in extent and are confined to the lowest levels of the troposphere. Fern or fawn. Fern is a hot wind of local importance in the Alps. It is a strong, gusty, dry and warm wind which develops on the leeward side of a mountain range. As the windward side takes away whatever moisture there is in the incoming wind in the form of orographic precipitation, the air that descends on the leeward side is dry and warm. The temperature of the wind varies between 15 degrees Celsius and 20 degrees Celsius. The wind helps animal grazing by melting snow and aids the ripening of grapes. Chinook. Fern-like winds in USA and Canada move down the west slopes of the Rockies and are known as. It is beneficial to ranches east of the Rockies as it keeps the grasslands clear of snow during much of the winter. Question 53. Q. Assertion A. Cyclones spin clockwise in the northern hemisphere and anti-clockwise in the southern hemisphere. Reason R. The directions of wind patterns in the northern and the southern hemisphere are governed by the Coriolis effect. In the context of the above two statements, which one of the following is correct? 2005. Both A and R are true and R is the correct explanation of A. B. Both A and R are true but R is not the correct explanation of A. C. A is true but R is false. D. A is false but R is true. Answer, D. Climatology, humidity and CYCLONES. Question 54. Q. Consider the following climatic and geographical phenomena.